Good day, guys. Hi, so we're doing a quick catch-up for maths learners who need some help, some very basic stuff to prepare us. Right? So I'm basing this off a few worksheets that learners have been given. If I manage to complete the worksheets, our learners should be well prepared. I'm going to start with very basic stuff and slowly build it up to more interesting examples. Right? Hopefully we follow as I go along. Right? My aim is not to complete everything, but just do some basics and get learners properly prepared, right? Together with the revision program that has been provided to the learners, this should amply prepare them. Right, so if I quickly start with a few examples. So starting up on some simple algebra, if I take an example like 12x squared minus 4x plus 6, right? Now this is an expression. Now we don't need to know too complicated fancy terms to get marks. We just need to know some basics, right? The important thing is you're looking at this. This is to the power 2, and there's no exponent above the x. Whenever there's no exponents, we assume there's a 1. So there's an invisible 1, and we got the number which is referred to as the constant. So some questions you can get regarding an expression like this. One will be, what is the degree of the expression? The degree refers to the highest exponent, and thus, so your degree in this example is 2. What is the coefficient? The coefficient is the number in front of what we need to know. So if I ask you, what is the coefficient of, for example, x to the power 4? In front, the number in front of the x to the power 4, sorry, no, that's not x to the power 4, there's no x to the power 4 in this example, x to the power 2. So the number in front of the x to the power 2 is 12. So the coefficient of x to the power 2 is equal to 12. The coefficient of x is equal to -4, because in front of the x is a -4. So coefficient in simple terms means the number in front of the x or y or variable, the letter. In simple terms, the coefficient is the number in front of the letter, in very simple terms. If they ask you what the constant term is, the constant refers to the number, and there's your number, that's 6. Your constant term is 6. And if I ask you what happens if I put x is equal to 2 into this expression, all you do is substitute. So all you do is this, write down the equation 12x squared minus 4x plus 6. Right? Substitute means you simply remove the x, and where you have the x, just remove the x. Let's do this. And in the place of the x, you put the number. In this case, that number is 2. So we put a 2 here, a 2 there. And when we calculate this, 12 times 2 is 24, minus 4 times 2 is 8, plus 6. Right, you end up with 30 minus 8, which is 22. Right, that's what we mean by calculate the expression if x or the variable or the letter equals, it could be anything. They can make it 3, -1, doesn't matter. You just substitute, you then use your calculator. Once you substitute, use a calculator, you'll get your answer. Thereafter, it's quite simple, right? Okay, let's do the same thing with another example. So if I take this off and create another expression, it doesn't matter what the expression is. Let's see if we can find another expression that might be helpful. Let's take 6x squared plus, 6x squared plus 3x minus 4. Let's say that is the expression. Now let's answer these questions for this expression. So let's change this, the coefficient of, let's take these answers out. Constant term will be different now. Okay, erase that. Eraser. Okay, thanks. Right, the magic of technology. Okay, I'm not going to spend too much time doing that. Very quickly, this is very easy stuff. The degree is, in this case, 2, the highest exponent. The coefficient of x squared is in what's in front of the x squared, so it's 6. The constant term, in this case, is -4, and x is equal to 2, so you'll go 6 and x squared plus 3x minus 4. You remove the x, and in its place, put the 2. So 2 squared, 2, and you put this in the calculator, and you'll get your answer. Right? That's very simple. Calculator will give you the answer. I don't want to waste time doing that. Right? Whatever answer you get, that's your answer. That's what I mean by substitution. Right, so a quick summary of that, very basic stuff. What if I had -3x to the power 4 minus 2x 2 plus 7? Right, let's summarize this. So the coefficient of x to the power 4 is -3, so that's a coefficient. The coefficient of x squared is -2. Right, so we got 2 coefficients in this example, -3 and -2. So the question would explain whether you want the coefficient of x to the power 4 or the coefficient of x to the power 2. Right, so it's -3 in this case, depending what the question asked. This, the number without a variable attached to it, is your constant. Right, constants. I got great handwriting, I know. That's the constant. And what else can they ask? Yeah, degree, coefficient, constant covers everything or most of it. And you can substitute whatever else, right? So this is your polynomial, and this, or an example of a polynomial expression. And we can answer all these questions. Very simple, easy marks for most people in an assessment, right? Okay, so I don't spend too much time on that. I think most people know that. Let's go on to the second type of question that can come up, and that involves patterns, number patterns, all right? So if I look at examples of number patterns, so I'm going to call this number patterns. And let's say I had a number pattern of, let's find an example very quickly that's maybe asked. Right, simple one, let's see, we had pattern 1, 3, 5, 7, 9, 11. So that's an example of a number pattern. We usually refer to this as term 1, term 2, term 3, term 4, term 5, term 6. And usually what this implies, it goes on and on, right? It's a repeating pattern, and we have to find the pattern. Now, let's say this is a very simple example. I'm sure most of you can see what the pattern is, but if you're not sure what the pattern is, then all you've got to do is subtract the second term from the first term. So you find this when you subtract this, 2, 3 minus 1 is 2. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So you've got yourself a pattern. Each time it's increasing by 2. So if we ask you what's the next number, well, it's 11 plus 2, which will give you 13. And you add another plus 2 there to give you 15, depending what they ask for. Right. Now, if you are unable to answer a question that involves patterns using the formula, it is fine. If you can get the answer by completing the pattern yourself, that is accepted, right? So you don't have to use the formula if you can find a way to get the answer without the formula. But it's good to know the formula sometimes when the values are too big, it's quite helpful. So if I ask you to determine a formula for this, very simple. We write the formula as Tn is equal to, you take this and you put it like this, 2n. That's the start. That's not the answer, but that's how you start it. So Tn is equal to 2n, right? Tn is equal to 2n. Now, what if I substitute? So now I want to see if this works here, right? If I substitute 1, I get 2. Does that match with what I have here? No, I have 1. This formula gives me an answer of 2. Right? So it doesn't give me that pattern if I just put Tn. What do I need to do to the 2 to make it 1? Say that again. What do I need to do to the 2 to make it 1? What about if I subtract 1? So 2 minus 1 is 1. And now I've got the same thing that I have here. That's why the formula becomes Tn minus 1. This is the formula. I just subtracted 1. Let's try. Now let's see if this formula works. If I go T1 and into 2n minus 1. Okay, so let's take that off. You'll notice what I did there, hopefully. And do that again. I need space to write on. So now let's try it with that formula. T1 is equal to 2 times 1 minus 1. 2 times 1 minus 1 is equal to 2 minus 1 is equal to 1. And that is equal to T1. That's what I want. If you're not sure if it works, try the next one. T2 is equal to 2, in the place of the n, put 2 minus 1, which is 4 minus 1, which is 3. And look at it, I have 3. That's what I want. That's how I know my formula is correct. Sometimes you just do trial and error if you're not sure. All right, let's take another example very quickly. Let's take, we'll keep it simple. Let's take 6 plus, all right, not plus 6, 9, 12, 15. Right, now first question, what's the next 2 terms? You got term 1, term 2, term 3, term 4. What's the next 2 numbers or terms? We're just gonna guess it? No, we're gonna figure out what the pattern is. So we look at this, 6 to get to 9, what do? We added 3. 9 to get to 12, we added 3. We added 3, and 12 to 15, we added 3. So obviously the next number, we're gonna take 15 and add 3 to it, and you're gonna get 18. And you can do the same if they want the next one, 18 plus 3, 21. So you're adding 3 each time. That's why it's a pattern, because each time you're doing the same thing over and over again. You just got to figure out what it is we are doing, right? So that's simple. Now, what if I ask you for the formula, right? Remember, you don't have to use the formula, but what if they ask you for it? The rule, sometimes you call it a rule, sometimes you call it a formula. Well, look how simple. I know it's going to be T is equal to 3n. That's it. Now, I'm going to go trial and error. Tn, let's try. If I put in Tn, if I go term 1 is equal to 3 times 1, I'm going to get 3. Is 3 the same as my term that I've got in the pattern? No, it does not match. So now I've got to adjust it. Somehow I've got to make the 3 equal to 6. How can I do that? What would make sense? I think it makes sense if I add 3, isn't it? So if I add 3 to this, it becomes plus 3, which is equal to 6. So 3n plus 3 is the formula, because 3 plus 3 gives me 6. That's what, but I'm not sure if this is correct. How do I know it's correct? Let's try it. Let's take the formula and try. Put in T2, let's see. So 3 times 2 plus 3. That's my formula or rule. 3 times 2 is 6, plus 3 is 9. Yes, I've got 9. It works. So that means this formula is correct. It gives me the pattern I have in front of you, right? I can do it for anything. I can do any number. Now, what if the question asks, what is the 25th term? So the question asks 25th term. Now you can go add 3 and 3 and 3 and 3, but you'll get old by the time you finish. That's how we create formula. So T25 is equal to, write down the formula. Sorry about that. The formula is 3n plus 3, right? So let's put in 25. 3 times 25 plus 3. And 3 times 25 is 75 plus 3. Your answer will be 78. There you go. That's all, right? Let's do, okay, but that is a bad example because, okay, I wanted to check it manually, but it doesn't matter, doesn't matter. Hopefully, remember, I want to spend more time on more difficult stuff. This is simple, right? That's how you get it. To get the n, you just see what it's changing by, and you decide how you're going to change it to match the first term, and then you can work with it from there. I'm just going to see if I can find if there's another example anywhere that I need to do. Sometimes they give you this in the diagram. Please don't be confused because you see the diagram. That does not mean it's any more difficult, right? So let's see if we can find. Okay, can't seem to find the diagram, and I'm too lazy to think of an example. Let's do this. Right. So you have sometimes there can be some diagrams, whatever the case may be, and you look for the pattern. It doesn't matter what the diagram is. So let's say you got something like 7 and 12 and 17. I'll just do the last one. Right? This could be, they could give you matches or some diagram, and you got to fill in and work out the pattern, right, of how we got it. Or they'll just give it to you. It depends on how the situation works. So, for example, they give you determine the cans in the bottom of any stack. Okay, so we can have some cans, whatever it is. So they got cans, and in the bottom row they got 7 cans. 1, 2, 3, 4, 5, 6, 7. And then maybe the cans get smaller in number and smaller in number, right? They will tell you whether they want the first row, second row, depending on the situation. I don't know, right? But let's just say this was the pattern, and the bottom row of cans had 7 cans, the second one was 12, the next one is 17. Once you read the question and know what they want, creating the pattern is not too difficult. Let's do it one more time the way I showed you to do it. Right, I need to find what pattern is. So easiest way, 12 minus 7 is 5. 7 plus 5 is 12. 17 minus 12 is 5. 12 plus 5 is 17. So I've got my pattern now. I know it's 5 each time. So obviously the next one will be plus 5. 17 plus 5 is 22. Now I want the rule or the formula. So I know it's going to be Tn is equal to 5n. That's it, right? 5n. Why? Because the difference is 5. We don't need to know about that. Now, I'm pretty sure it's not going to work. Or maybe it does. Let's try it. So how would I try it? I substitute 1. Because this is T1, T2, T3. So let's substitute 1. So it'll be 5 times 1, which is 5. Is my answer here 5? My answer is not 5, it's 7. What do I need to do to turn the 5 into a 7? I need to add 2. So I do that to the formula. Therefore, there's your formula. Tn is equal to 5n plus 2. Tn is equal to 5n plus 2 is the answer. It's the formula. It's the rule. Now, if I wanted t, let's take any random number, 7. I can do it by adding 5 each time. That will take a long time, but you can do that, and it's 100% correct. Or you can go T7 is equal to 5n plus 2. And where you got n, you just put in 7. And you work that out. That's 35 plus 2, which is equal to 37. There you go. Right? Once you understand that, you look forward to doing some of these pattern questions. They're not difficult. Okay? Thankfully, I'm right with regard to that. Just check if there's more difficult, any of the worksheets that I need to cover. No, that's it. That's it. Okay, so that's the first part of this, right? That's the first part of it. Now, I'm going to go on to the algebra part that people, for some reason, don't necessarily love as much. And exponents, and it's a lot of rules you've learned over many years that have to come into play. But anyway, let's assume you forgot many of those rules. COVID time, I can understand people's memories have gotten worse, right? Let's start with something simple. Right. First rule of exponent, anything to the power 0 is equal to 1. So it doesn't matter what it is. If it's 10 to the power 0, it's equal to 1. If it's y to the power 0, it's equal to 1. It can be 1 million to the power 0, it's equal to 1. So first thing we need to understand that anything to the power 0 is equal to 1. If we are aware of that, then it becomes simple. It doesn't matter. It could be in this form. 2x squared plus 10xy plus 7x doesn't matter. It's to the power 0. It's equal to 1. Right? That's the first thing we need to understand. And usually we get some questions that involve that. So when it comes to exponents, anything to the power 0 is equal to 1. Right. Now also it depends on where that 0 is. You got to be careful. That position of the 0 is very important. So if I had something like this, 6x to the power 0y, and let's say y squared. That 0 is attached only to the x. That 0 is for the x, sorry. That 0 is for the x. There's no exponent here, it means it's 1, there's a 2 here. So the 6 stays, the x becomes 1, and the y stays. Anything to the power 0, only the x is to the power 0 in this example. So it becomes 6 times 1 is 6y squared. You don't have to show this step, not necessary. You can go straight to the answer, it's fine. But anything to the power 0 is 1, that's always true. But you got to know what is to the power 0. So if I had 30 to the power 0 times x, y to the power 0. Let's see. 30 to the power 0 is 1. X is just x, it's to the power 1. Y to the power 0 is 1. Now there's no signs between this. Whenever there's no signs between anything in math, it means multiply. So it's 1 times x times 1, which is x. Right? Anything multiplied by 1 stays the same. So x times 1 is x. 1,000 times 1 is 1,000. 20 times 1 is 20. xy times 1 is xy. Right? Anything to the power 1 stays the same. Anything to the power 0 becomes 1. Okay, so there's some places that you might see something like this. So I'm just trying to point that out to you. Okay, so hopefully that helps. Let's see if I can find more examples from this worksheet that we need to know and that I can somewhat help you with, right? Okay, so then you get multiplication. You need to understand how to do multiplication, right? So for example, if I had x to the power 2 times x to the power 3, please note, x to the power 2 times x to the power 3 is the same as x to the power 2 times x to the power 3, right? Or x to the power 2 times x to the power 3. Brackets, no sign, dot, all of this means the same. It means multiply, right? And the rule when you're multiplying, that's first thing, when you're multiplying and the bases are the same. The x is your base, the numbers on the top here are your exponents. So your base is x, so x times x, the base is the same, you add the exponents. So 2 plus 3 is 5, so that becomes x to the power 5. So when it comes to multiplication, the rule is if the bases are the same, you multiply the, sorry, if the base is the same, you add the exponents. Right, very simple. And that's a very basic rule, but we need to understand it. If I do another example, x, y squared times x to the power 2, y to the power 3. Let's say I ask you to do this. Now, there's your one x, there's your other x. Write down the x, because you're multiplying, the base is the same, and you add the exponents. You've got 2 here, there's no exponent. Whenever there's no exponent, you put down 1. So it's 1 plus 2, and you've got the y, and there's 2 here and 3. So 2 plus 3. So the base is the same, you write on the base, you add the exponents. So this becomes x to the power 3, y to the power 5. X to the power 3, y to the power 5. Yes, I know I have wonderful writing. X to the power 3, y to the power 5, there's your answer. Right, very basic, but you need to know it. So if I now go to further, more interesting examples, what if I gave you something of this effect? X to the power, sorry, 2x to the power 2 times 3x to the power 4. How do we work that out? 2 times 3 is 6. So 6, write down the base, which is x. 2 plus 4 is 6. Very simple. There's your answer. Right, it's going to get more complicated. So say, for example, I put 2x to the power 3, and I use the brackets. So I put in 4xy. I'm just creating these sums. Don't think they mean anything. If you can do one sum, you can do all sums. Right, again, brackets. Brackets means multiply, right? So 2 times 4, okay, I don't want to do that and confuse you. 2 times 4 is 8. X 3 times x. Base is the same, write down the base and add the exponents. 3 plus 1 is 4. There's no y except for this 1. Let's use a different color. So you'll leave it as y. There's your answer. All right, multiplication, very simple. Things that we should all know, but just to remind you so we know the basic rules of it. Right? Now these rules do not change. I don't make up these rules. These rules from now to grade 12, to university, to end of time will be the same. You might still learn it now and they'll help you later in life, right? These are rules that don't change. They're very important, right? So we know how to multiply basic terms, right? Of course, it will get more difficult and more interesting, but let's look at it. Can I find a more interesting example to multiply? Okay. What if I did something like this? 2 to the power x squared into 3x minus 4x squared y. That now has gotten to a slightly more interesting level because what this means is you have to multiply this term with this term, and then you're going to multiply it with this term. So there's two sets of multiplications happening. So everything outside the bracket must be multiplied with everything inside the bracket. There's two terms in the bracket. The 2x squared must multiply the 3x, and you must multiply the other term. If you're finding it difficult to understand that way, you can write it this way. 2x squared times, okay, let me take out the brackets because some learners don't like brackets. 2x squared times 3x. That's the first one done. I should have used red there, doesn't matter. And for the other step, it's 2x. Okay, easiest thing to do is just write down the sign, minus, and it's 2x squared times 4. Okay, again, I'm using brackets, and I prefer brackets, but I know learners don't like brackets, so I will do what the learners prefer. So 2x squared into 4x squared times 5. Just have a look at what I did. All I did was write this down and write this down. I'm reminding myself of the multipliers. Now I got two separate sums. I first have to do this. Once I've got that answer, then I do this answer separately. But it's multiplication, so we've been doing multiplication up to now. Multiply the numbers first, then multiply the letters in simple terms. So 2 times 3 is 6. You can use your calculator. If the numbers are difficult to understand, if you don't know how to do integers, negative times negative, positive times negative, use a calculator. Use the calculator, it'll give you the correct answers. Calculators don't lie. They don't give wrong answers. You do the wrong thing, you'll get the wrong answer. 2 times 3 is 6. Now we're multiplying bases x. 2 plus 1 is 3. There's the answer for that. Minus 2 times 4. 2 times 4 is 8. x2 times x2. Write down x. Add the exponents. 2 plus 2 is 4. And you've got y. Since there's no other y, it's y times 1, which is y. There's your answer. Leave it. Don't confuse it. Can't simplify any further for this one. All right, so let's see if I can make this any more interesting. All right, so let's say I had negative 2a into 4a squared minus 3a b plus 4. Okay, there's it. We're multiplying now one term with 3 terms. So I need to multiply 3 steps. This, multiply with that, step 1, then step 2, and then step 3. And it's 3 different multiplication steps in one problem. So minus 2, okay, So okay, I'll write it down here, but later on I'm not going to show each step like this. It's time consuming, but there's nothing wrong with doing each step. It's safer. So it's minus 2a times 4a squared. That's step 1. Then it's minus 2a times minus 3ab. That's the next step. And finally, you've got minus 2a times 4. So you notice when you have more than one term in brackets. Now, how do you know the difference in terms? I know the terms because this is term 1, this is another term, and this is term y. They're separated by plus and minus. They are separated by plus and minus signs. That's why they are terms. So now we just multiply for each one. So minus 2 times 4 is 8. Use calculator if you have to. I'm going to go a bit faster. I'm hoping we're catching it now. And you are adding exponents. So a 1 plus 2 is 3. Thereafter, you've got minus 2 times minus 3 is positive 6. If you don't understand that negative and a negative is a positive, it doesn't matter. In every calculator, you can put minus 2, you can put times, you can put minus 3. It'll give you the correct answer, positive 6. You just want to learn and get used to your calculator. You don't need a fancy, expensive scientific calculator. Cheapest 5 Rand calculator, get an Osman's, works. Okay, inflation, I don't think you can get one for 5 Rand, but any cheap calculator works. So don't be afraid to use a calculator. Minus 2 times minus 3 is positive 6. A times A is A. Okay, so it's 1 and 1. So 1 plus 1 is 2, and B. And with this one, it's let's use green. Minus 2 times 4 is minus 8. 8 times 1 is 8. There's your answer. Right? You're following steps, and if you follow the steps, you won't go wrong. Right? You won't go wrong. So hopefully, multiplication isn't a problem for most learners. If you understand that in terms of multiplication, then everything hopefully would be a bit easier thereafter. Right, you can complicate things by putting, let's see. All right, so you can complicate multiplication by doing something where the exponent is on the outside. So if I look at where the exponent is on the outside, so let's take, there's a rule that says that we got a to the power x brackets y. Your answer is a to the power xy. In other words, you multiply x times y. You multiply x times y. So x times y is xy. Right? That's just a rule. I can prove it and discuss it, but we don't have time. And you know what? We're just trying to get marks. We're not worried about how we get it, as long as we get the correct answer. So the rule is, if you got an exponent and another exponent with brackets, multiply the two exponents. So let's take an example that might be easier to understand. If I had a to the power 2 to the power 3, 2 times 3 is 6. So 2 times 3 is a to the power 6. You just write a to the power 6. You don't have to show the step. I'm writing the step to explain. If I had y 6 to the power 3, you simply go 6 times 3 is 18. So it's 6 times 3, y to the power 18. That's your answer. Right, let's see. If I had, okay, so let's make it more interesting now. What if I had 2x to the power 2 to the power 2? What would you do here? Right, now, because it's brackets, it means that 2 exponents on the outside belongs to everything. So remember when I said when there's no exponent, there's an invisible 1. So it's 2, 1 times 2 is 2. X, 2 times 2 is 4. Right? So now this is 2 times 2. You're working with powers here. 2 to the power 2 means 2 times 2. And 2 times 2 is 4. X to the power 4, there's your answer. Let's see if there's, let me do one more like this. Let's say I had 3x to the power 2 to the power 3. Let's see, is that any more difficult? Right? Understand that this means 3 to the power 3 and x squared to the power 2. So it'll be 3 to the power 1 times 3 is 3. X to the power 2 times 3 is, okay, yeah, 2 times 3 is 6. There we go. Now, to the power 3, however you wish to do that, I know the answer is 27. How do I get 27? When it's to the power 3, it means 3 times 3 times 3. That's what the power means. And you got x to the power 6. When you work that out, 3 times 3 is 9 times 3 is 27. X to the power 6, there's your answer. Right? Once you know these rules, it doesn't matter what number, what variable, the rules don't change. And then it becomes a bit easier to work with from there. I hope you understand that. Right? I'm trying to find any interesting example like this that can cover that might be something you need to know. No, okay, we covered most of the time. Right? But that's fine for now. Now we know how to multiply. We know x to the power 0 is 1. And thereafter we got division, addition, and subtraction. Okay, when it comes to addition and subtraction, right? Let's say I had, okay, just take an example, x to the power 2 plus y to the power 3 plus x to the power 2 plus 2y to the power 3, right? Even if I put a, let's put a negative somewhere. Let's put a negative here. Right. Now, this is no multiplication, it's addition, right? So when you're adding variables or terms, the rule is you can only add like terms. You can only add apples to apples. You can't add apples to oranges. What I mean by that is x squared, x squared. Those are the same terms. That's an apple, that's an apple. So if I had 1 apple plus 1 apple, I'll have 2 apples. But what is an apple? X squared. So x squared plus x squared is 2x squared. If I take this, let's see, y3 and y3, are they identical? Yes, the y3s are the same. So that is an orange. So let's see. That's -1 orange plus 2 oranges, right? Which works out again. You don't know how to do that. Negative and positive, use a calculator if you have to, and you'll find your answer is +1, right? We don't have to write down the 1, and it'll be +1 y3, right? So in this case, we've got 1 orange. If we had 2 oranges added to -1 orange, right? Okay, just note that rule means like terms. You can only add like terms means they have to be the same in terms of x squared, y3, y3. You cannot add x squared to y3. That's apples and oranges, right? So the rule is you can only add like terms when it comes to addition, right? So note the difference between addition and multiplication. Okay. All right, so now the next type of question that you need to be able to solve is in this worksheet, binomial. Okay, let's take another example of it. So if I had, for example, 2, stop writing, 2 if I had 2 x squared minus 4ab plus 6ab plus 10x squared. Let's say this was a sum given to you, right? And we ask you to calculate the answer. Use colors. There's x squared. Do we have any other x squared? Yes. So that's 2 apples plus 10 apples is 12 apples. X squared being apples. If I had, let's see, AB and AB. So those are bananas. And I've got -4 and then +6. The numbers you can do in the calculator, -4 plus 6 is +2. Right? Of what? AB, yes. So you're doing the numbers on the calculator if you have to, if it's numbers are difficult for you, which some of you I know it is. And A, this doesn't change, that doesn't change. Right, there you go, that's your answer. That's simple, right? So very basic work that we should not be getting wrong, right? That's how we add, or that's when we add stuff together. Right, multiplication is covered. Then we need to go on, everybody's fear, right? What can be difficult? Before we do that, let's see if I can combine some stuff here. Right, I'm just going through some random examples. If I had 2a to the power 3, a to the power 6 to the power 3. Right, how we do this? A rule of maths, always do brackets first. So I'm going to start with this part. Ignore that. So I'm leaving it as it is. So 2a to the power 3. So you're left with a. Now what's the rule when you have this case? Multiply. So a 6 times 3 is 18. So that becomes 6 times 3, which is 18. Right, now the brackets means we can multiply. How do I multiply this? 2 times 1, there's no number, is 2. The bases are the same. If the base is the same, you add 3 plus 18 is 21. There you go. That's the answer. We're just using different rules together at the right time. The rules never change. The sum gets more complicated, but the rules stay the same. And if you know the rules, it doesn't really get that much complicated as long as you follow the rules and use the right tool at the right time. Okay, if I had something already, let's say, I'm going to do that for last because I know how everyone loves division, and I don't want to cover that just yet. Okay, let's do a few more examples. Now, let's take a negative. So negative 2a squared. Okay, let's keep it simple. Let's keep it simple. People are getting tired now. Negative a squared. Remember, I'm looking at a worksheet. I'm trying to teach for that worksheet. And for some of your learners, worksheet is a code that I'm not going to reveal because in case learners from other schools see this, they might think, why is this so easy? So multiply this with that, multiply this with that, multiply that with that. So I'm going to get each one minus a squared times 4a. Then I'm going to get, let's use a different color, minus a squared times 3a to the power 3. Right, let's cover that. And then minus a squared times minus a to the power 4. Right, so do each one separately, we'll get our answer. So minus 1 times 4 is minus 4. A2 times A1, write down the A2 plus 1 is 3. Right, with this one, minus 1 times 3 is minus 3. A to the power 2 plus 3 is a to the power 5. Then you've got minus 1 times minus 1 is minus 1. A to the power 2 plus 4 is 6. Is your answer. Don't need anything else. Right? Let's say I gave you some, okay, that's sorted. We covered some multiplication, right? I'll come back to binomials later for those that know about it. Don't worry about it for now. And yeah, that's it. Multiplication. Let's go. Right. So now, if we know multiplication, we know division, we know addition. You covered most of it. You just have to practice using it in different types of scenarios and examples, but that's the basics that you need to know. If I get you to know that, if you didn't know it, I am more than happy with what I've achieved, right? But you have to practice it, that's the problem. When it comes to division, basically if I had a to the power x over a to the power y, when you're dividing and the bases are the same, so you got a and a, you simply write down a and you subtract the exponents. So x minus y. Right, but that's difficult to understand. Let's make it simpler. So if I had a to the power 4 over a to the power 2, it's division. So it's a4 minus 2, which is a to the power 2. So when you're multiplying, you add your exponents. When you're dividing, you subtract your exponents. So a to the power 4 minus 2 is a to the power 2. There we go. Right, hopefully we're okay with that. Let's do another one. X to the power 7 over x to the power 3. is equal to, since we are dividing x, 7 minus 3 is equal to x, 7 minus 3 is, right? Okay, sorted, hopefully. Right, now, how can I make this more interesting? Well, we throw in numbers to add to it, right? So if I had 4x to the power 6 over 2x to the power 2, let's see what we get here. 4 divided by 2. Now again, if you don't know numbers, and I'm using very simple examples, but as I said, the method stays the same. 4 divided by 2, you can do in the calculator is 2. X, 6 minus 2. You don't need to show that step. Is 2x, 6 minus 2 is 4. There we go. Right? What if I had, let's see if I can anything more interesting. Let's put some numbers now. Let's put 20 x to the power 4, y to the power 6 over negative 4x to the power, or x and y to the power 2. Right, what would that answer be? Right, now I'm getting tired. It's end of the day, long day of teaching, and I'm gonna pretend I'm giving you time to figure it out. Meanwhile, I'm giving myself a small chance to have a break. Right, that's enough. 20 divided by negative 4, right? Again, calculate if you don't know how to do it. Negative 5. x4 divided by x1 is x to the power 3. Y 6. All right, I'm going a bit fast now. 6 minus 2 is 4. 4 minus 1 was 3. There you go. So when you're dividing, bases are the same. You subtract the exponents. You subtract the exponents, right? So I'm looking some of the examples that we might come across. And do that. Okay, we're winning. I'm covering most of it. Okay, here's a nice example. 8a to the power 4, b to the power 8 divided by 2ab. Next example. What do we need to do? 8 divided by 2 is 4. How do I know that? Calculator. Your best friend is a calculator if you're very weak, right? And then a 4 to 4, when you're dividing, it's 4 minus 1, and b, that's 1, so it's 8 minus 1. So it's 4, a 4 minus 1 is 3, b 8 minus 1 is 7. Right, remember this middle step here is optional. You don't have to show it. You can do it straight and subtract, but I'm just showing so that you follow, understand, and any problems, you can work from there. Right, there we go. Simple, easy mark till we get something to that effect. Right, no matter what they do. Now remember, now this is where the problem is. That learners get confused. They forget when to use which rule. And we should not do that. And it comes to practice. So what if I now go and give you a multiplication, right? Do we remember the multiplication rules? What if I gave you 3p squared r to the power 3 times 2p squared times p to the power 4 r to the power 3? Right? Looks complicated. We're multiplying. Remember, 3 times 2 times, there's nothing here, so it's a 1, is 6. Now we look for common things. You got p, you got p, we got p. So write down the p. 2 plus 2, the exponents plus 4, right? So that's 2 plus 2 is 4 plus 4 is 8. Done. Then you realize, let's get fancy new color for the highlighter. Right, okay, no, yellow. All right, then we got R. Then we've got, there was P, I write it properly, and then you got R here, right? And if I do that, I'm writing down the R, you're multiplying, the bases are the same, add your exponents. So that's 3, and that's 3. So 3 plus 3 is 6. There we go. Right, let's do one more division. I'm just going randomly now, but the whole point is to use rules. And I find when I mix it up, sometimes it forces your mind to remember some of the rules because you're not going to get it in any assessment in order. You're not going to get addition. It's going to be mixed up. It's going to be combined. And that's why some of us get caught out. So let's go 12x to the power 3, y to the power 3, z to the power 3 over 3x to the power 0, y to the power, what is that, 3, and z to the power 3. There's no magical way to do this. It's the same way all the time. 12 divided by 3, you can use a calculator, is 4. Now we're dividing x. So 3 and 0. So it's 3 minus 0, y, 3 minus 3. And z, oh, also 3 minus 3. Okay, 3 minus 3. Somebody likes threes. So you got 4, 3 minus 3 is, sorry, 3 minus 0 is 3. Y 3 minus 3 is 0. Z 3 minus 3 is 0. But where do we end up with? 4x to the power 3. And I'm going to leave it there. That's the answer. And if you forgot why that's the answer, you weren't paying attention or you already a little bit forgot from the beginning of the lesson. Anything to the power 0 is 1. And anything multiplied by 1 stays the same. So your answer is 4x to the power 4x to the power. Right. Okay, so that's done. I don't think, I'm just seeing if I covered the one example I need to. Yes. Okay. So a few examples. We know how to multiply. We know how to divide. I think what's remaining is how to use brackets. Right. How to use brackets. Yeah. Okay. Let's see if this will trick anybody. What if I gave you 2x squared times, okay, let's make it 2x squared divided by 4x to the power 3 to the power 0. What's the answer? The answer is 1. Anything to the power 0 is 1. You don't need to work out what's in the bracket because no matter what, even if you work it out first, the answer is still going to be 1. So there's no point doing it. Right? The answer is 1. Okay, now let's look at multiplying a binomial with a binomial. For some reason, some learners love this and some learners don't. And I've got to now find a way to explain it in the short time that we have. Okay, let's see. Okay, let's do it. Let's do it. Let's do it. Nothing to fear, but fear itself. Right, if I have a plus b times a plus b, right? What would that answer be? Right, let's look at it. Right, there's many ways to explain this. People love this. This is the FOIL method. You don't need to know what it's called. You go that times that, step 1, that times that, step 2, step 3, step 4, right? And you get your answer. That is perfectly correct. There's nothing wrong with that. But it's also but tiring and learners make mistakes. So I find the easiest thing to do that with is this. Create a box. So you got a plus b, a plus, okay, sorry, a plus b, right? Let's write this better, a plus b. So we multiply this times that. A times a, it's 1 to the power 1. So you're adding exponents. 1 plus 1 is 2. Then you've got b times b, right? So in any order, b times b, that's 1 plus 1 is 2. Right. Now, so a times a is a squared, b times b is b squared. Now, how do I get this? Let's try a different color. So so that times that, right? These two multiplied will give me what goes in that block. So a times b, and a times b is a times b. And do the same with this two, that with that. A times b is a times b. Right. Now, we've got a squared. We've got b squared. But we've got AB, we've got AB, right? Now all these are to be added. So AB plus AB, as discussed before, 2 apples plus 2 apples is 2AB. There you go. You add when the terms are like, I didn't add a squared and b squared because a squared and b squared are not like terms. They are unlike terms. They're apples and bananas. You can't add apples and bananas in maths, right? So it's a squared plus b squared, separate because you can't add them. But I had AB and AB. AB and AB are apricots. One apricot plus one apricot is two apricots. There you go. Right, and all I need is a final answer in an assessment. You don't need to do the full visits. You'll get full marks for that, right? And as you're working out, show this. You don't have to show all the other steps. You'll still get, as long as you get the answer, this is a quite safe way of doing it, so you don't miss up steps. We'll practice with another example, not to worry. Let's try. Let's see if I can make this any more interesting. Okay, let's take x minus y, x minus 2y. Okay, let's make it plus. Right, we want to multiply this binomial with this binomial. Binomial means two terms, right? So I create my box. Okay, I don't know why I made it bigger. Maybe because of the headache, and my headache is getting bigger. So maybe that's why I'm writing bigger, right? So, sorry, I am talking to myself, right? So x minus y, x plus 2y. Did you see what I did there? X I put here, minus y I put. So each one has an allocation there. Now, essentially, I have to multiply this with that to get that answer, right? Then I need to multiply that with this to get this answer. Then I multiply the x with that to get that answer, and then that with that to get that answer. That's what I'm doing, right? So let's do it. I'm just removing that, and let's do it now. So x times x is 1 plus 1 exponent, which is 2. Right, why this is lovely. This is, if you can do a sum like this, it tests your multiplication, addition, right? When to use each of those skills. And that's why this, I love this. When I know learners can do this, binomial to binomial, and get it right without a doubt, those learners have potential. Right, then x times 2y. Well, 1 times 2 is 2, x times y. X times minus x. When you multiply that, you get minus xy. And y, 1 times 2 is 2, y times y is y squared. Right, now, everything in the block, everything in these blocks need to be added together. Everything in this block needs to be added together. But I only have one x squared, so I can't add it to anything. And I only have one y squared, so I can't add it to anything. So that's why the answer is just going to be x squared plus 2y squared. Okay, if you're wondering, it doesn't matter the order. I can put the 2y squared here. That's fine. You don't need to put it like that. It's just that we are used, as a math teacher, I'm used to doing that, but you don't have to. It's still correct if you put it like this. Then I realized that this here and this are like terms. Xy and xy are the same. Right? So now I'm doing apples, apples. Xy is an apple. So is the other xy. 2 apples minus 1 apple is 1 apple. So it's plus xy. There's your answer. Right? Here's your answer. Hopefully that makes sense. Now, remember, this is using multiplication and addition. The last step, after you fill in the blocks, so you got your 4 blocks, then you're adding your 4 blocks. Then you're using a different tool. Like terms, you can only add, right? You can only add like terms. Right, let's do another example. I don't know, 3x plus 2xy. Let's put a square. Okay, now that's too simple. All right, let's put it next. Okay, let's leave it. Let's leave it. And 2x minus 4. Yeah, let's leave it. But I don't make it too complicated. The point is we understand how to do it. And right, okay, so let's draw the table. I know there's 4 terms, so I'm putting 4. Right, so I'm filling in. Let's use some colors because I have it. 3x plus 2xy, 2x minus 4. Now multiplying. I'm multiplying this with this first. Let's see, 3x times 2x is 6x squared, right? 3x times -4 is negative 12x. Then you're multiplying 2xy times 2x. 2 times 2 is 4. X times x is x squared because 1 plus 1 is 2. There's nothing to go with the y, so it's just y. And then the final step is multiplying the 2xy with a -4. So -4 times 2 is -8 xy. There we go. If I did that correctly. Okay, this is a terrible example. Okay, but anyway, it's not terrible. It's still correct. Now let's see. Any like terms? I've got 6x squared. Any other 6x squared? No. I got 12x. Any other 12x? Any other x's? No. Any other x squared y? No. Any other xy? No. That's what's a terrible example. But anyway, it's fine. So my answer is 6x squared in any order minus 12x plus 4x squared y minus 8x y. That's it. Right? There we go. Right, why do we have more answers here, more numbers, or more variables, sorry, more terms? Because there's no like terms to cancel. That's it. Right. Let's do another one. Should we? Or are we finding it's too easy? Right. Let's do another one. Oops. Okay, sorry, it's my phone. 2x minus 4. Okay, let's do this. Sometimes they write it like this for you, right? And we should know that x squared is equal to x times x. So what this means is 2x minus 4, and you repeat it, 2x minus 4. That's what it means. So which means now I can go back to my table, which I'm enjoying a lot right now, right? And I write it down, 2x minus, oh, sorry. Now I'm getting tired. 2x minus 4, 2x minus 4. Right? Now, let's try to make sense of this. We need to multiply. Start with this 2. 2x times 2x is 4x squared. Then do this 2. 2x times minus 4 is minus 8x. Thereafter, you're multiplying minus 4 with 2x, which gives you negative 8x. And minus 4 times minus 4 is positive 16. There you go. So when I write it out now, looking for like terms, I got 4x squared, no other x squared, so it's 4x squared. I've got 16, so 16, right? Now, notice I have like terms. It's exciting when you see like terms in maths, right? Because this is x and this is x. They're identical. So now forget x, think of apples. So I've got minus 8 apples, minus 8 apples. And minus 8 apples, minus 8 apples is minus, 16 apples. There you go. That's your answer. The order doesn't matter. Whether you got 4x squared minus 16x plus 16 or 4x squared plus 16 minus 16x, the answer is still correct. Right? It's right. I have this inkling of doing one more of this. So if I had x minus 4 into x plus 4, what will the answer be? Again, however it needs to be done, let's set it up. I'm going to go my table, any method, but the answer will be the same. Whichever method you're comfortable with, this is just the method I think might help learners, but you don't have to do it this way. All right, so x minus 4, x plus 4, right? We know the steps, that with that. That's x times x, x times x is x squared. X times 4 is 4x, right? That times that. Then let's do minus 4 times x is minus 4x. And finally, minus 4 times positive 4 is negative, and positive is negative. 4 times 4 is 16. If you're not sure, your calculator is your friend. Your calculator will help you if you know the rules. If I get my answer, it's x squared. There's no other x squared. I've got negative 16. There's no other number, so we just leave it. It's negative 16, nothing to add it. But look carefully. Look carefully. Exciting terms. My 4x. So that's okay. Let's explain that again. You've got x and you've got x. They are like terms. You've got red apple and red apple. So that's 4 red apples minus, so there's 4 apples minus 4 apples. So it's positive 4 apples minus 4 apples. And 4 minus 4 is 0. So I don't need to write down the 0. There's my answer. This answer is x squared minus 16. Right, that's how you multiply binomials with binomials. That's how you multiply binomials with binomials, right? It doesn't matter how complicated it is. If you use this method and you follow the rules of multiplication, addition, exponents rules, you cannot go wrong, right? You cannot go wrong. Right, I hope that makes sense. Are we okay with that? Okay, good. All right, I'm gonna leave it up to this point for now and maybe do more examples at a later stage, depending how we feel about it. But for now, I'm gonna stop there. So running out of time. Right, thanks for paying attention. Goodbye.